Well, I think I got enough done to at least get a prototype demo video. Still got a lot of work to do as far as getting the audio files done, some more control, interlocking, look ahead stuff. Currently looking into a linear encoder option that looks promising. It'll be a spring-loaded encoder mounted to the pusher assembly and be driven by the rack. Won't be able to do on-the-fly changes, but if I set up a distance error, I should be able to do a move, a separate move to correct for it, maybe. But we're going to have to probably break these videos up into two parts. It'll probably take a while. But we'll show you the progress we got so far. Here's the main menu, and we'll start with the maintenance screen. Here we have our PLC inputs, our outputs, and here's some of the HMI setup stuff. We have our show the usage. We have the communication protocol stuff here. This will probably never change, but at least have the option to change it from the screen. Here we have the sound control. I want to be able to turn that on and off, as it is only really helpful for first-time users. And here we have the Fast Select toolbar, which is like a Windows start bar. You can put commonly used windows in there, and that Fast Select is on every screen, so you can get to stuff quickly. You have the System toolbar, which is some of the more in-depth HMI setup. The mouse cursor, and here we can delete all recipe data simultaneously. And the most useful screen in the maintenance tab here is the manual force window. Here we can do jog forward and reverse, and we can do relative moves. So right now I have 10 inches in there. That's not based on any known distance. If you just tell it to go 10 inches forward, it's going to go 10 inches forward, which I think will be useful for checking your backlash. You can zero your gauge, tell it to go forward, and then tell it to come back, see if it comes back to zero. Here's some of the speed setup. We have the relative move run speed in inches per minute, and I have the ramp as a percentage of the total move, and that'll show your actual inch distance on the accel decel. And here we have the jog speed. Here we have the sensor feedback, stuff you want to know right on the screen for easy use. Here we have some stuff you can force. We have the rack blow off. I don't have a clean cycle programmed yet, but you can force on the pneumatic blow off. I have two nozzles, one on the gear rack and one on the very top edge of the bearing rail to blow dirt and debris off the back gauge. Here you can enable and disable the stepper motor, so you can move the assembly by hand. And here we have if the Ironworker was on, we can do an auto punch. I just recently got internet and wireless out to the shop here. I do have this machine set up through VNC, so I can remotely control this whole setup from an iPad or a laptop wirelessly. I think the only time that you'd ever do that is using this screen. If you want to check your sensors, if you want to check flag, gaps, If you want to look at anything else on the back gauge, you can be right where you're working at and not have to be tethered to the HMI. I do have my laptop set up on the conveyor. We can test that function. So all you need to do is log in, and we're live with the machine wirelessly. So here we can do, you can jog forward, jog reverse, and we have 10 inches on the relative move. We'll go 10 inches back. That'll flash red when it's in motion, green when it's in position, and back to a numeric input so you can change it. And we'll come back to where we were. Do it 10 inches forward. So now we're back to where we started. You can turn on the rack blow off. Can disable the stepper motor. So now I can move that by hand, and we'll re-enable the stepper. So it's a pretty cool function. Unless I get a robotic arm to load the steel, I think the only time you're going to use it is with this screen. But so we'll close this connection. And we'll go back to the HMI. Okay, we'll go back to the main menu, and we'll go to System Setup. Here we have our accel decel profile. I'm not entirely happy with this. There's some, I guess, limitations with myself and with the pulse train output here, but some of the limitations are with my current operating system on the PLC does not allow for separate accel decel ramp distances. They have to be equal. The other issue is you can't set up, you set up your whole back gauge to, you set your distance from 0 to 127 inches, and I wanted to say 25% ramp, whatever. If you do a 100-inch move, 25 inches is going to be the acceleration. So after 25, when it gets to, or after 25 inches is gets completed, it's going to run at top speed for 50 inches, and then it's going to decel for 25 inches, which is ridiculous. If you do a 1-inch move, from 0 to quarter inch is going to be 0 to whatever 500 inches per minute. That's your speed, so I just break the belt doing stuff like that. So here we have, you can select your range. So if it's greater than 0, less than or equal to 2, this first range has to be a percentage. It has to be floating, because you cannot have a combination of your accel decel be greater than your total move. So you can't just say an inch distance for that. The rest of them, you can set up an inch for your accel decel, but it has to be less than 50% of the minimum in your range. Because like I said, you can't have a accel decel greater than your complete run distance. I do have this, at least these are set up for dynamic limits. I don't have these set up, so you can't, just watches you, so you can't have overlapping ranges. I think I set the minimum to like 1% of the minimum, and the max is 1 inch. So that's 50% of 2. And here you can set up the inch per minute speed of your ranges. So if we select all these, you can change them individually. or you can change what you want by percentage. So now we have 10%. So you can turn them all up together, or just the ranges that you selected. So it works okay. Still got to sit down and actually figure out what the most linear profile would be. But so that's the accel decel. Here's our homing routine. This is a return to home. It also doubles as the job complete, return to home sequence. But here's our rapid inch per minute speed back to the home sensor. This is the ramp distance for the accel decel, and that number will never change unless you change the physical distance between the homing sensor and the registration sensor. If it's short, then it's gonna, once it flags the registration to ramp down to the homing, it'll fall short and it'll get a homing routine timeout fault. And here is the registration speed. So that's the speed from going forward from the homing sensor back to the registration. So it takes out your backlash and make sure you're starting at the same point. And I gotta change this too. I have it set up so that if it's flagging either of those sensors back there, that it'll auto come forward to pass those sensors and then go back and do the homing routine. There's no real reason to do that, I don't think so. But what we have so far here is, this is the inch per minute speed to move off of those sensors forward. Your accel decel in inches, and how far you want it to come forward to clear those sensors. And this screen was in the other videos, but we'll explain it. Here's the step pulse per inch setting, and this will never change either unless I change the drive multiplier. Here's the max usable length right now. To do a recalibration, I guess like a first time, if this was 0 or whatever, you just home the back gauge, take your tape measure, measure to the center of the punch, just get it close, enter that value in this box. You set my calibration distance to 1 inch, which is just about the whole back gauge length there. And depending if it's shorter or longer than the calibration position, you'll get your difference will be plus or minus, and that will add or subtract from the back gauge length automatically. So that makes it easy to recalibrate. I'm not wondering, I haven't tested it, but like if you change punches or whatever, if that makes a difference. But it might not hurt to just do a quick check before every job. And you can see these are all grayed out, everything's interlocked, so once you hit the calibrate, you can't hit that again, and you can only update after it's been in position. And here's the anti-backlash. There is none right now, so I'm not too worried about it. And here we have our punch delay setup. These values are for the very first position in your recipe. I have that set up for a longer pulse count, give the operator time to get everything squared up and ready for the punch. So right now I have it set up for the sound alarm 3 times, 1 second on, 1 second off. Oops. For a total of 6 seconds. And this button right here will allow you to play your alarm track, so we can do that now. So if I want to change that to 2 seconds on, I only pulse 2 times, you can play. So you can customize the first punch alarm to whatever you want to listen to. And here is our punch delay time after the first position. So 2 through 100, when it gets in position, it's going to wait 1 second before punching. And this button here turns on the sound alarm for every punch, and that'll sound the alarm for the length of time of your delay here. Here we have the as part of the faults. If you fail to reach, say the downstroke sensor in 3 seconds, it will abort the punch, come up with a fault, and give you your restart options. You're running a job. Same for the upstroke. So that's pretty much it for some of the behind the scenes setup, and I'll have to resume this in part 2.